Station, this is Houston. Are you ready for the event?
Houston, we are ready.
Halo team, this is Mission Control Houston. Please call station for a voice chat.
Station, this is Rick Mastracchio with the Halo team. How do you hear me?
Hey, Rick, we have you loud and clear.
Hi, Megan. Hi, Thomas. Thanks for talking to us today. We're calling you from the Dulles, Virginia Mission Operations Center for the Northrop Grumman Cygnus cargo vehicle that just arrived to you guys on orbit. As you probably know, Northrop Grumman Space is also designing and building the habitat and logistics outpost for Halo module for the NASA Gateway. With me are a few of the key folks who are working hard to build a habitat that's safe for the crew and will provide access to the surface of the moon for many years and decades. Of course, we're working very closely with the NASA engineers and astronauts here on the ground, but we wanted to give the crew on orbit a chance to provide some inputs to our overall effort. So I'll give a quick intro to each of our engineers, and then I'll hand it over to Mike to them for their question. How do you hear?
And Rick, we copy all that loud and clear. It's great to be talking with all of you today. I know that you bring a lot of your own experience to solving these problems, but we're happy to get to chip in our 2 cents as well.
Yeah, that's great, Megan. We appreciate it. First up is Catherine Ludwig. Catherine is a mechanical engineer and lead for the internal design and layout. Catherine?
Hi. In the Halo module, and eventually the expanded gateway, humans will be spending more time farther from Earth than ever before. At NG, we're acutely aware that this is a huge step for humankind, and we're incredibly excited to be a part of it. What can NG do in our design of the Halo interior and layout to make the experience of living in cislunar space comfortable and familiar, and to help the crew feel connected to home?
Well, we love to look out the window. We're actually standing right by the window in the lab, and you can see I've got some cameras over here. It's one of our favorite pastimes when we have some free time. So having the ability to look outside, whether it's out of windows or using cameras, I think would be very valuable to the crew members on board to sort of see that. Of course, it'll be much farther away than we are from the Earth when orbiting the moon, but I still think that ability to look outside and look around is going to be important. Another thing that's very important is the audio quality. So we expect the environment to kind of always have a background noise. There's a hum of equipment going on all the time. But what you really don't want is something that's really loud and disruptive, that, when something cycles on, it makes, kind of a startling noise. So unexpected noises, of course, are not a good thing. But we do realize, obviously, that it's going to be a noisy environment. And then the other thing that I'll mention, I think that's really important for fostering a good team environment, is the ability for each crew member to have some privacy, so a space that they can retreat to, as well as a space that can foster kind of a group gathering. So it's really fun to get together for a meal, at the end of the day, swap stories, that kind of thing. So I think both of those things, the ability to have some privacy and the ability to spend a little bit of group time together, are important for a strong team.
Thank you, Megan. All right, so next up, Megan and Thomas, we have Michael Corrigan. He's a harness subsystem lead engineer. Michael?
Oh, hello. Similar to the ISS, Halo will have some external equipment and payloads, and is designing options to allow EVA operations for maintenance activities. What is the most difficult part of EVA operations on the ISS, and are there some aspects that the engineers designing the Halo exterior should be considering in order to increase the ease and efficiency of EVA operations?
It's a great question. I think I'd say the most difficult part of EVA is when you're inside preparing to go out. I mean, it takes a long time. It's a very complicated, difficult procedure. It's very involving, not only for the EV crew member, but also for whoever's helping them getting to the suit and getting prepared and getting all the tools ready. So I think if you can take that into account into the design and try to make it as easy as possible to get that part done, that would already be great, I think. Once you're outside, I would say standardization is the key. Sometimes on the ISS, it's so vast, it's so huge, it's built in different countries by different people. So we go out with a bunch of tools because every fastener is a different size, and that kind of bites us sometimes as far as being efficient in our work. So try to make everything as standard as possible. I think also the hardest is to get to your work site and stabilize your body. Once you're in a good body position and you're stable, the tasks are usually easy to perform. So try to have that in mind when you design the layout of the outside, how those guys are going to get there, how they're going to stabilize themselves at the work site. And finally, I would say the concept of ORU, orbital replacement unit, is hugely important. You cannot get an electronics box open, outside. So you have to be able to exchange the entire box, again, in a standard way every single time. So I think if you take that into account, then it'll be a pleasure doing an EVA closer to the moon.
Yeah, thanks, Thomas. That was a great answer. We agree with all that. Next up, we have Staten Longo, and Staten is the utilization lead system engineer.
Hi, Staten Longo here. We plan to have accommodations for 8 payload lockers inside Halo, with connections built into the back of the lockers. Do you have any recommended improvements for payload installation or removal efforts, or moving payloads from one location or module to another?
So as I'm sure you know, we do have modular payload lockers up here as well. We have an example that we can show you. And so there are some tricks associated with working with those. We have to be able to attach this locker using this long tool that Thomas has, with the bolts up against the back of the rack. And so we have this alignment guide that helps us to do that, but there's nothing that helps us align with the bolts. You're kind of just eyeballing it. And one of the things you'll notice on Space Station, we've got cabling everywhere, and that's because the power and data and even water cooling goes in at the front. And so that makes it a little bit simpler when you're having to change out payload racks, but it doesn't give that sleek look that people are expecting, from watching movies. And so when the connections are going to be at the back, so a blind mate connection, what you need are really robust connections, and you need really good alignment guides, and you need a solid feedback to the crew to tell them when everything is properly aligned and connected, so that we don't damage any of the connectors when we're moving things around. So I think those are kind of the big things to be thinking about when designing modular payloads, and I think it will look great to not have all of the cabling everywhere.
Yeah, Megan, we agree on that one. It's amazing the number of cables up there. Okay, next we have Keenan Wolf. Keenan is on the fault management and system autonomy team. Keenan?
Thank you, Rick. Thank you, Megan and Thomas, for taking the time. Halo will host the top-level vehicle system manager software, as well as the Halo-specific module software that will balance ground, onboard crew, and autonomous command and control of the gateway system. What is something that you are tasked with or do at regular intervals that you wish you didn't have to, or you think could be handled autonomously?
It's a great question. I think there's already quite some autonomy on board the ISS. I mean, maybe not on board, but tasks that are invisible to us, the crew, because they're taken care of by the ground or by the system. Sometimes we don't even know which one is taking care of which. But I think some tasks that seem to be coming back regularly are mostly related to, I think, the E-Class system, the life support system. We seem to be like draining tanks into other, switching pumps off, on and on, switching valves, etc., to keep the systems in good shape, to keep our water balance, nice and happy the way it's supposed to be. And if I think it seems like if this could be automated a little bit more, that would probably be great.
Thanks, Thomas. When he asked me that question, I said vacuuming, but yours was much more sophisticated. So next up, we have Shawnette Adams. She's the Senior Human Systems Integration Engineer. Shawnette?
Hello, this is Shawnette. Halo is being produced with detailed attention to crew safety and vehicle reliability. Based on your previous flight experience and your current experience on ISS, what equipment would you consider safety critical based on current usage?
Well, I know you've gotten lots of requirements documents that talk about what things are safety critical for us, and so I know that you're already thinking about those things. And for us there, the obvious ones are, of course, the ability to respond to an emergency that we might encounter. So a fire, a depressurization, or a toxic chemical release into our environment. So how do we protect ourselves from that? How do we respond to that? How do we safe the system? And if necessary, how do we safely get back to our vehicle that will take us away from there? So all of those things I know you're already thinking about. We have things as simple as, glow-in-the-dark dots that tell us which direction to go if all the power went out to get to our safety vehicle. So there's all different levels of those kinds of safety measures. As well, of course, redundancy in all of our critical systems. So command and control, obviously the life support system will be especially critical, and that will include the ability to recycle the air and the water, of course. All of those things are safety critical. And I would add on to that in terms of what we do every day. The ability to exercise and to stay healthy is really important to the crew, as well as to be able to respond to medical emergencies.
Great. Thank you, Megan. As you can imagine, safety is our number one concern, and we're doing a great job to build Halo and keep you guys safe, but also make it a comfortable place for you to work and live. So next up, we have Sally Richardson, and Sally is the Halo Program Director, and she's leading this great team of folks. Sally?
Thanks, Megan, and thank you, Thomas, for taking the time to answer all of our Halo design team questions. This is great. So we also got a number of questions from our Twitter feed, and we have a couple of social media questions that we wanted to pose today. So one question is from Steve Goyet, and he's asking about Windows on Halo. And we had one from Swarupa from Mumbai on how similar Gateway will be to ISS. So I'm going to answer those questions first, and then I have a question for the crew. So Halo is based on Northrop Grumman's Cygnus module, and it's currently designed to use with ISS. It's about the size of a small studio apartment. So it doesn't have windows right now except in the hatches, but we will be getting a cupola-like module that does have windows coming up and being supplied by ESA, Thomas. And that will dock with one of Halo's radial ports. So, but within the smaller design, my question to the crew is going to be, how do we prioritize space utilization for your self-care, for performing experiments? Even though Gateway will not be occupied year-round, it's still important that we really provide you with safe and useful accommodations, and that we provide standard self-care utilities. So what significant considerations would you consider that we have on our priority list as we're laying out our internal design?
Yeah, I think it's a great question. It's a great concern to have. I would think, I know Halo is not going to be huge, but I think if you can have in mind to try and separate the different areas based on which utilization you're making of them, it's not great to have everything at the same place. If you're going to exercise, sleep, work, live in the same 2 meter square, like everybody's getting in everybody's way, and you're missing that privacy sometimes that Megan said was important before, and I agree. So, for example, what we don't have here up on the ISS is a real shower area, hygiene area, so we kind of make do with what we have, but it would be nice to have an area that's dedicated to this, in which you can leave your stuff, and then in which you wouldn't care about droplets floating everywhere. So I think if you manage to somehow in that small volume kind of separate and dedicate some areas to the different uses that are being made, I think it's going to go a long way as far as ease of use and crew morale.
Okay, thank you for that. So I understand we have time for one more question. So I'm going to pass it over to Staten to follow up.
Hi again. So bonus question. What are the biggest challenges when working with payloads and performing payloads or robotics operations? And likewise, what works well?
So one of the challenges that we face on a regular basis is that payloads come up all the time, and they're often things that we don't know anything about. We haven't seen them before, and we're operating them based on a standard set of skills that we have and that we've trained. So it's one of the things I love about my job is that I'm learning something new every day. I'm learning about different people's research, and I'm representing them basically in space and conducting their research for them. So that's very exciting, but it can be challenging if you don't know exactly what the expected outcome is. You don't know how the equipment operates. You maybe haven't seen it before. So making sure that the systems are robust, that they're well designed, that the crew has resources to get answers to questions when they come up, when maybe things don't work as well. So that might be real time, being able to speak to the investigators on the ground, but it also might be resources that the crew has access to on board so they can respond to any questions they have about the payload operation real time.
Thank you, Megan. And you guys are getting all the questions right, so we're going into the bonus round now. We got one more question from Shawnette.
Hello, this is Shawnette again. What are some of your favorite crew tasks, and what suggestions do you have for crew efficiencies?
It's a great question. I think for long duration missions, routine is a factor. Whatever you do, if you end up doing it every day, at some point it kind of takes the fun out of it. I mean, we try to take a step back and realize we're in space, and then suddenly it becomes cool again. But sometimes I think everything that's new, everything that's gonna surprise you a little bit or challenge you a little bit, or require you to adapt or to change the way you're doing things, I think generally speaking is what we like. We like when a new vehicle is coming up because there's new experiments that are going to be deployed and operated, and it's exciting for everybody. We like when there's an EVA that comes up because it's different every single time. So I think that element of breaking the routine is important no matter what the task is.
Thank you, Thomas, and thank you, Megan, both of you, for the great help today. We're working hard down here. The Halo team is working hard to give you guys the greatest vehicle that we can get for you up at the Gateway. And I think that's all the questions we have. We're just about out of time, but I just want to say enjoy the SS Ellison Onizuka up there. We hope you enjoy the cargo that we delivered, and it'll help you clean house once that vehicle leaves. Again, have a good day. We appreciate your great answers.
Thanks a lot, Rick. It was a pleasure being with you. And they're actually working on the Cygnus cargo as we're talking to you. If you see in the background, there's all kinds of bags floating because those guys are working hard on the cargo. So thanks for what you're doing, and then looking forward to seeing the result of your work orbiting the moon.
You bet. Thank you.
Station, this is Houston ACR. Thank you. That concludes our event.
Thank you to all participants from the Halo team. Station, we are now resuming operational audio communications.